Alright, so this is the hardest example in exercise 3D. It's tricky, it is a proof, it's got quite a few things going on. So in the question here it says you've got a string that's wound around a disc and there's a horizontal length of the string between points A and B, which is 20 centimetres. So just looking at the picture here, I'll do this in green, that's the string, okay, there, and it's between points A and point B, it's 20 centimetres long. Now the radius of the disc is 10 centimetres, so I'll do that in a different colour, purple. So you've got this radius here of 10 centimetres. The string is then moved, so the end of the string is moved to a point at the same level as O, which is the centre. So the centre there of the circle is O. So what you've done is you've effectively pulled the string up. And you've pulled it sort of up that way. So now if you have a look, it's a little bit hard to see in this picture, I think, but this is the point A and this is the point B dash. We call it B dash because it's a new point B. It's not the same point B we had before, but this is the same piece of string. So the piece of string actually wraps around a piece of the circle here and then goes straight for this section. So there's actually two pieces here of the circle to consider. This part here around part of the circle and then the straight part. Okay, we have an angle theta, and we also know that because this is the radius of the circle, we actually know and can label that this is 10 centimetres here. Okay, now looking at the part A, it says, can you show that theta satisfies the equation pi on 2 minus theta plus tan theta equals 2. Now straight away what I see is this tan theta, and I can see I've got a triangle here. Okay, tan is opposite over the adjacent, tan theta opposite over adjacent. So that means I'm going to have to do something. I've got the adjacent, it's 10. I'm going to have to do something here with this piece of the string. Okay, and I know that this piece of string here is 20 centimetres. There's also a little piece of string here which we want to find. Okay, everything we're going to do here is going to deal with this picture. So what I'm going to do, I'm just going to actually take this picture here. We'll put it on the next page and then we'll work with it. Okay, so the first thing I'm going to do, I'm going to try and find this little piece of circle here, the round piece. Now I know that in class I showed you the idea that if you have a circle, oops, do a better circle than that, and you have a segment of a circle, it's subtended in the centre there. So let's say that this angle is 30 degrees. Okay, we know that there's a 360 degrees around this interior of the circle. So in terms of being a fraction of the circle here, we know that that would be 30 degrees over 360 degrees, bit of cancelling, which would be 1/12. So this slice here is 1/12 of the total circle. What that also means is that the slice has 1/12 of the area of the circle, and it also means that the slice has 1/12 of the circumference of the circle as well. So if we were to think about that and 1/12 of the circumference, that links to what we're looking at here. We're actually looking at a little piece. So just focus, all I want you to focus on for now is this little slice here, okay, of the circle. So we can try and find this part of the string. Now what we need is a bit of information. Firstly, we need something about this angle in here. And going back to the question, the string is moved so the end of the string is the same level as O. So that's right here. So we've got a straight line. I've also got a straight line going down. So what you can see is that this is actually a right angle here. This is 90 degrees altogether. So this angle inside here would be 90 degrees. Take away theta, because theta's there. Okay, so we're now dealing with a slice like that, where we've got an angle of pi on 2, take theta, and we're interested in knowing this length of green here, the length of string that's around this part. So what we can do is figure out first of all what fraction of the circle is this slice. So slice is a fraction of the total circle, and it's going to be, put equal signs there, pi on 2 minus theta all over 2 pi, because remember that 2 pi is that distance all around the interior of the circle, 360 degrees. So with this, you might want to simplify that because it's quite ugly. So I'm just going to simplify it. I'm going to put everything on the top over a common denominator, oops, which is 2. It's still over 2 pi. So that's pi minus 2 theta all over 2, and all of that's over 2 pi, and that's over 1 if you think of it that way. So you've actually got two fractions, the top fraction, the bottom fraction. These two go together and the 1 would go up to the top. So in terms of a fraction of the circle, this slice here is pi minus 2 theta on 4 pi, 2 times 2 pi. So that tells you what fraction this is. Okay. Now the circumference of this circle, total circumference, oops, C, is 2 pi r, and we know that r, the radius for this circle, is 10 centimetres. Remember looking back at the question, we know what the radius is. So if we know that, we can substitute that in. 2 pi times 10, which is 20 pi. Okay, so in terms of this part here, the circumference, this is actually going to be a fraction. This is our fraction. So fraction of total circle. And we want to find that fraction of this circumference, which is the total. So let's do that on the next page. We know that the total circumference is 20 pi. Actually, while I'm here, it's a good idea to put a box around that. Okay, so this is the circumference of the slice. I should say actually this is often called a segment. I've just been calling it a slice because I like calling it a slice, but it is also called a segment as well of a circle. So it's the fraction times the total circumference of the circle, which was 20 pi. So the two parts there, if you want to label them, that's the fraction of the total, and this is the total circumference. Okay, so you could do a bit of work there. You could pause the video and actually see what happens there, what cancels. And hopefully you've said the pi's cancel, and also the 20 turns into a 5. So we now have, for our circumference, 5 times pi minus 2 theta. So that's going to be the part of the string, around the circle. I can't remember if this was a disc. It says it's a disc. It's the part of the string around the disc. It's the little green part. And we'll just put that in a box so we can find it again. So that's one part done. So let's look back again. I'm just going to copy this picture again because we've actually found a piece of that string now. Remember that the whole goal here is trying to find some relation with theta. Put that back. Okay, we have what this part is here. Now remember that this entire length, the whole green length, all of that is 20 centimetres. That's what it started as. So you can see, oops, you can see that going back 20 centimetre length. Okay, so because we've already found this part here, we know that this part that's in green, and I'm actually going to do it in a different colour. I'll do it in yellow. this part in yellow is actually going to be a side that we know now. It's 20 centimetres. Take away what we know this to be, and we know that this part here, this section of the circle, is 5 pi minus 2 theta. So this is 20 minus 5 pi minus 2 theta. That's what this part is here. So let's actually rewrite this. Pick up this triangle. We've got a nice triangle like that. We've got theta, we've got the radius of 10, and we now know this side here. So you can see the method to my madness, which is, looking back at the question, it wanted something to do with tan. So let's deal with tan now. We know tan theta equals opposite, 20, take 5 pi minus 2 theta, over the adjacent, which is 10. And all I'm going to do now is just expand that out. So I've got 20, take 5 pi plus 4 theta all over 10, like that. Okay. Oh, I should say, not 4 theta. It's a bit odd. 10 theta. All over 10. Okay, so all I've done there is I've expanded this part, making sure that I take the negative sign too, so it's a negative here, but it's a positive here. Okay, and then you can see a little bit of simplifying. So you can see that we therefore have tan theta equals 20 divided by 10 is 2, 5 divided by 10 is a half, it's a half pi, 10 divided by 10 is 1, so that's theta, and this is very close to where we want to be. I'm just going to put this again on the next page. So there's quite a few steps in this, and it's all just about not giving up. Always keeping your eye on the prize, which is this. So if we have a look now, I'm going to take this over because we're going to now solve part B as well. So our goal was to try and show that theta satisfies the following. And you can see we're really close. All we need to do is rearrange. So therefore, tan theta, that's cool, that's on the right side. Let's move the theta over and the pi on 2. This is pi on 2. So therefore, pi on 2 plus theta plus tan theta equals 2 as required. Boom. So there's been quite a few steps there. The key one being identifying the little piece of the string there as a segment of the total circle, figuring out what fraction of the circle it is, which is this. It's quite ugly looking, but keeping with it, okay? Keeping your eye on the prize that this is the circumference here. It's a part of the circumference. Total circumference is 20 pi. The fraction of the total circumference is this fraction times 20 pi, which gets you to here. So we know the part of the string around the disc. We now know that this part of the triangle here is 20 centimetres. Take away the part we found that's now attached or now stuck against the disc, which is 5 pi minus 2 pi in brackets, minus 2 theta in brackets. And then we just took this triangle and just dealt with that on its own. And that was just tan theta. That's all trig. Opposite over adjacent. Bit of rearranging. So it gets you where you want to be. The last part, because it says 2 decimals, it's so exciting because it means we're nearly there. So for part B, because it says find the value of theta corrected 2 decimal places, you can use your CAS. So use your CAS for this. It's probably a good idea here to actually look at your picture and estimate. You can see here that theta has to be less than 90 degrees. Bigger than 0 degrees, but less than 90 degrees. So actually put that into your calculator. So I'd do solve. I'd put your expression in there. Solve for theta, but then solve it such that theta is between 0 and pi on 2, or 90 if you're going to be working in degrees. So we'll do that. We'll put that one in. Put that in the CAS. Put everything there. So we're going to have solve, and we've got pi on 2. If you don't want to use theta, because it's awkward to find, you can just use anything. I'm just going to use, I'll use a t. T for theta plus tan theta equals 2. Solve it for t such that and make sure that t is between 0 and also pi on 2, which is 90 degrees. And you're going to get 0.9399. Now the question's asking you for to 2 decimal places, so that would be 0.94, rounding this up. So theta equals 0.94 radians with the little c. Okay, if you were working in degrees, then it would be degrees, depending on and you get a different number there. So the key thing here with the proof, keep at it, just work at the different pieces, don't try and do everything at once. So break it down, for example, into a circle segment and a triangle. That's commonly what you break these down into. And then as soon as you get to the solution part, put it into your CAS, but also specify a domain so that you don't get all the different answers. Have a look at the picture to help you decide what that suitable domain is. You can see it should be less than 90. So that straight up gives you the single answer that you needed to solve this question. A very hard question and the hardest proof that's in the workbook.